Okay, so, all right, gravimetric analysis. And that's what your lab's going to be on. Gravimetric analysis. All right, what does gravimetric sound like to you guys? What is it? Gravity. Basically, all you're doing is precipitating some products, and you're going to filter them. And then you're going to mass your product, and then you're going to figure out, do a whole bunch of calculations with that. So this is like a fancy way of saying you're doing filtration. Okay. So I'll read you what I wrote down here. Determining percent composition from a precipitate precipitates mass, usually an ionic compound. Two ionic solutions undergo a precipitation reaction. Knowing the original amount of ionic compounds and the mass of the precipitate, we can find percent composition of a cation or anion in the original compound. So basically, what is this? Using a precipitation reaction to find percent compositions of ions in a compound. So kind of like working backwards. So I'm just deciding whether to give you a sample problem or just use the lab. You know what? We'll just do one right now, and this will be good for Chi-Chi and Taylor anyway. So, all right, I'll give you a sample problem here. That's an example of this. We'll go over it. We'll kind of do it together, and then we'll hand out the lab, and I'm going to have you guys work in groups on the pre-lab, so this will help with that. And then I got to get just a couple things set up for that intro activity, and then we'll get going with the lab. All right, so here we go. A sample of an ionic compound. So let me make space. A sample of an ionic compound. So make sure you write this question down so you have something to look at when you're doing the pre-lab. Sample of an ionic compound with a mass of 0.250 grams. Is this marker dark enough for you guys? It is. Okay. So I try not to like throw them out too early and kind of waste it, but it starts to get too light. Okay, so a sample of ionic compound with a mass contains the Br-1 ion. Okay, a solution of this compound, I'm trying to paraphrase it, it's actually longer than this. A solution of this compound, or sample, sorry, a solution of this sample compound, same thing, is treated with excess AgNO3. What does that mean? Why is it telling us that? Why is it telling us excess AgNO3 then?
So that we know that the compound is limited.
Okay, we know the compound's limited. Good. So what do we know about the compound? We only know one thing so far. What is it?
Just 250 grams.
We know the mass, right? 0.250. And what else do we know that's in the compound?
Br minus.
Right. So Br minus here is limiting. This is excess. You should already be familiar with the solubility rules, right? And what happens. What's going to happen when you mix a beaker that has Br minus floating around, and then you dump a bunch of silver nitrate? What's going to happen? It's going to precipitate. What is that precipitate going to be? AgBr. Right. So the point of this whole question so far is that you understand all of these Ag pluses are going to precipitate all of the Br. So all of the Br in the precipitate, there is one more sentence I'm going to give you, but all the Br that's in the precipitate, it was in the original compound. That's the whole point of that. Okay, so now it says a precipitate, I'm just going to abbreviate PPT, that's the abbreviation here. A precipitate is formed with a mass of 0.464 grams. Alright, the question here is what percent of the original sample is BR? So calculate the percent BR in the original sample. You with me, Paige? Yeah. So again, gravimetric analysis. It's like a fancy word for saying, okay, you're going to take two solutions, mix them. You're going to get most likely a white precipitate. You're going to isolate that by filtering it and then massing it. That's all gravimetric analysis is. You take the mass of your product or precipitate, and you can take that and apply it to the beginning compounds and figure out some information. If you don't know it, and a lot of times, like with water, you don't know exactly what's in there, but if you precipitate all the ions out, you can figure it out. That's what this is. So like the hardness of water, that's what the lab's about. So that's the concept, right? So hopefully you're starting to understand what we're doing here. You take solutions, you may not know a lot about them, maybe just a little bit, you know what's in there, and then you precipitate it, and then you can actually get a concrete number, a quantity, based on the product. So really, here's the concept. Can I erase this? We're good? So here's the concept. So you have an unknown compound with Br minus, right? So just say XBr, you treat it with AgNO3, you're going to get AgBr, and then XNO3. Doesn't matter what X is, it's not going to precipitate because nitrate is super soluble. So this is irrelevant, and so is the X. So really it's Br minus plus Ag plus yields AgBr. Okay? And it doesn't matter what the stoichiometry is and the coefficients, because if this is excess, literally all of this is right here. Okay? So if you know the mass of this, you can figure out the mass of just the Br, which is the same as that. Then you can figure out the percent. Once you get the mass of part of it and you know the whole mass, percent's easy. So there's your concept. I do want to give you a couple minutes on your own or talk to somebody near you. So I gave you the mass of this. All of the Br here is here. See if you guys can do this. Take a couple minutes. This is more of the same of what we've been doing. The empirical formula problems. I give you products, you have to work backwards to get the reactant. It's the same concept, just different type of problem with solution here, all right? So I will stop talking. Feel free to talk to each other, see what you can do. And I'll give you a hint. Your percentage of BR is above 50%. If that helps. Welcome back, Scott. thinking, or are you done? Here, you know what? I know you guys want to know how you did on that quiz, so while you're working, I'll just call you up here one at a time so you can see how you did. Tristan. Yeah. Better. Paige. Yeah, that. Yeah. Yeah. That's pretty good. Cal. Ben. Luke. Taylor. Nicole. That's the same, right, as before? I think it's the exact same. Yeah. Liz. Trevor. Better. It's a lot better. All right. Yes. All right, I'll give you another minute. See what you guys can come up with. And listen to me. Please don't like freak out if that grade isn't, as good as you wanted it to be or whatever. Okay? Trust me, I've been in your shoes. You may not believe me, maybe you don't know. I was obsessed with getting good grades in high school. I was convinced if I didn't get like 100 on everything, I wouldn't get into a good college. No matter what my parents told me, that no one ever put pressure on me. I did it to myself. So I think some of you are like that. So I get it, but trust me, all right. And I'm not like this old like wise man. I'm not old yet. But anyways, I do know a little bit about just teaching for a while and living long enough that if you want something, it will work out. Trust me, it will work out. So whether you get a 70 on a quiz or a 60 or an 80 or whatever, try not to get focused on like that one quiz or test and then like really obsess about it. Just get through it. You'll do better in the future. And trust me, whatever you guys want to do, you have any idea what you want to do? You want to go in the military. You're going to go in the military. Whether you fail that quiz or pass it, doesn't matter. It's not going to affect that. You know what you're going to do? What do you want to do? Accounting? Okay. You're going to be an accountant. That's what you want to do, whether you get a 2 on this AP test or a 5. Okay? So please believe me when I say that. So I'm not saying blow things off. Always try your best. But things will work out. You want to do what? Something to do with animals maybe? Yeah, you will. So I know it's hard sometimes. I've been there. Some of the grades on that, if I was you, I would be upset. Like, I get it. So, all right. So it's not just a pep talk. It's like that's really how life works. If you want something, you work at it, you'll get it. Yeah, you may not always do as well as you want, but you're going to end up doing what you want to do. I told you guys I got a D in inorganic chemistry, right? I am a chemistry teacher. I teach AP Chem, trying to get college credit. And I almost failed a college chemistry class. That I tried pretty hard in. So, and I'm a fairly smart person, so just, keep that in mind, all right? Anyways, that's my pep talk for the day. Anyone get an answer? 78.8? Yeah, let's go over it, and then we will do the lab. All right, so here's the concept, right? The mass of this is 0.464. So what I'm going to do is turn that to moles. So there's a couple ways to do it, but this is the easiest way. I'm going to take this number, all right, multiplied by 1 mole over the molar mass of silver bromide, which is 108 plus 80. So that is 180. I got 187.8. I guess I used the exact numbers there. 187.8 grams. Grams cancel, so I get. I didn't write this number down. Who did anyone do this way? 0.00247. Okay, 247 moles of AGBR. I'm going to stop there though. Why am I doing that, Nicole? Yep. If you have 0.00247 moles of AGBR, that means you have 0.00247 moles of BR minus, because it's a 1-to-1 ratio. There's one AGBR has one BR. So that's how many moles I have here in the original compound. Now, what do I do? Tristan, what do we do now? Right. So we want, this is going to tell me grams of just the BR. Right? So I know the whole mass of this, which is 0.250. So if I get just the mass of BR, I can do part over whole times 100. So moles of BR times the molar mass of BR, I got 0.197. Are your numbers off a little bit now? 0.197 grams of BR. So that's how many grams are in, right? So XBR, this part of it is 0.197. The whole thing is 0.25. So 0.197 divided by 0.25 times 100. Like I said, I got 78.8%. So that's how we do it. Lab, we're going to practice this some more. I have some other problems that are a little bit harder than this. It's a little more complex. We'll do the lab first. So the rest of this period, which is, there isn't much left. And then all next period, we'll be working on the lab. I guarantee, since we only have one period left essentially, we're going to be working tomorrow as well. I think today we'll do pre-lab, the intro activity as a class. That's probably going to be it. And then tomorrow, I'll let you work with your partners to kind of write down your procedure, how we're going to do the lab, and then we'll depends on how long that takes. You might end up just setting up the lab, and then Friday we'll actually do it. So, all right. Oh, we haven't done this yet. Write your names on a little piece of paper. That's how we pick the groups. We'll put Chi-Chi and Taylor. Oh wait, we have 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have to have one group of 3, and then 4 groups of 2. So Skylar, we're gonna put you with a group of 3, just to make it a little easier for you. Okay.